Good morning. Thank you all for joining us today. We'll just start with a couple of introductions and then dive right into the material. So I'm Rich Fulcher.
I'm Dave Chiu.
I'm Zach Gibson.
And I'm Bethany Fong.
And we're all designers working from across Google, from Android to Chrome, concentrating on bringing material design to Google's apps. And we're just kind of personally, we're really thrilled to be here this morning to really get to show off this work that we've been working on for quite a while now, so thanks for coming. Yesterday's keynote introduced material design, which is a new visual language focused on creating bold, graphic interfaces. It takes the principles of typography, position, scale, and color, and uses those to build really wonderful interfaces. Material design combines these classic print design principles with the kind of innovation that you can achieve through the application of technology. It takes elements that were formerly static and makes them reactive and responsive. It receives energy from the user's finger, from their mouse click, and it directs that energy to power transformation and animation of the material itself. Material design is also one adaptive design. So it's a single design system that covers handheld and web devices. It covers a variety of different form factors. Now, this is important because it enables the user to leverage the mastery they gain in one context and apply it to another to get that sense of intuitiveness that comes from being able to do that. In this session, we're going to discuss how material design affects the way you design the interaction of your applications. We're going to cover three major topics today. We're going to start by talking about the materials themselves and the properties of those materials that guide how you use them. That will lead into a discussion of structure, which will cover both kind of the level of how do I structure individual scenes or views within my application, and then up to how do I structure my entire app. And finally, we'll end by looking at some of the standard components that are kind of novel for material design and go into a bit of detail about how you can apply them that are particularly important. So, since material is the metaphor that powers this entire system, let's start by talking about two of the fundamental ones, paper and ink.
In material design, every pixel drawn by an app is a dot of ink on a piece of paper. Paper is on its own colorless. Ink can be any color. Each piece of paper wants to be a simple shape with rounded corners, a rectangle, a square, or a circle, which is, after all, just a square with extremely rounded corners. Paper does not want to be a star or a triangle or the shape of your app icon. Ink is much less restricted. It can flow into any shape. Measured in the X and Y axes, both paper and ink can have any size. Paper can fill the entire display such that you can't see the edges, or it can be the size of a single button. The size of ink is limited only by its need to stay on paper. But paper has an absolute fixed thickness equal to one dip or density-independent pixel. Now, why is that important? Because we must now consider the z-axis when laying out content. As a quick refresher, the z-axis is perpendicular to both the x and y axes, allowing us to position surfaces in front of or behind other surfaces. Paper surfaces are intuitive and natural, but to maintain that materiality, we layer and move them in ways that could plausibly fit within these devices. This means we constrain paper's behavior based on the perceived z-depth of the device. So for a phone, that's the distance between your thumb on the screen to the back of the phone against the palm of your hand. Monitors and televisions support perceived z-depth greater than their physical dimensions, in part because we don't physically handle the devices. The position of a piece of paper gives the user hints about how it relates to other paper. The dimensionality invites interaction. When the user sees a realistic shadow, they think there is a gap, we call it a step, between two pieces of paper, and they will behave and move independently. When there is no shadow between two coplanar pieces of paper, the edge they share is instead a seam, and the movement of those pieces of paper will be linked together. Paper always occupies a single z position. It is always flat, never tilted so that one edge is closer than another to the user, and it does not flip over to show the other side. The z position of paper is also a reflection of content hierarchy. Paper with a z position closer to the user typically contains content you want the user to focus on. such as a dialog box, or when you select a date in a calendar and it expands and moves forward from the grid. Paper with a Z position that's higher also tends to affect underlying content. An obvious example is the navigation drawer, which appears above everything else because it changes the displayed content. App bars are another obvious example. With material design, rather than thinking of depth as ornament, so adding a few drop shadows here and there and calling it a day, use depth to help users understand how your app works, how content is organized, and the scope of actions. So let's talk about layout. How do we take all the possibilities of this system and present them in a coherent and consistent fashion?
In all of our material design layouts, we strive for consistency, a cohesive experience across all of our apps. This starts with the fundamental structure of how we build our applications and layouts. The history of graphic design has given us tools like keylines, baseline grids, aspect ratios, and the use of incremental spatial relationships in our designs. These tools are the building blocks that we use and we need to create consistency in our designs across mobile, tablet, and desktop. Historically, the best graphic design work has come from a deep understanding of a grid structure, so that when it's used to its full potential, or even when something breaks this grid structure, it can be done in exciting and innovative and delightful ways. So there's a visual design talk that's happening later today, and it's going to cover a bit more details about the grid structure. But for this presentation, it's just important to note that our grid system is based on an 8-dip increment. So it's nothing new, really. If you've been working for the web, these are very familiar and friendly numbers. You'll find that our headers, icons, paper elements, padding, margins, buttons, etc., are all numbers like 16, 24, 32, 96, 960, 1024. You get the idea. They're all familiar and friendly numbers to us. We're just baking this into the system for the sake of consistency and visual harmony across all of our screens. So with our grid now in place, I think we're ready to start designing some apps.
OK, so how do the properties of paper and ink affect the way that you actually structure your app? So when you construct any particular screen, we've found it best to start from paper. That's the material that's really going to define the architecture of any scene or view that you're going to construct. And it's going to call out what elements kind of are surfaced above or below or can move independently. You can always come back and do ink as kind of a second pass. You've got your paper laid out, then you can fill in, as you would just kind of draw it in, all of the controls, all of the content as a later action. We spent a lot of time actually cutting out pieces of paper and layering them and moving them till we came up within the system with views that made sense. I really got to hone my scissor and glue skills working on this project. We even use things like little wooden discs here to track the floating action button, which is a highlight component within material design that Bethany will go into more detail about in just a couple of minutes. So playing with paper is a great practice for just getting a sense of how this design system works. It really gives you a feel for how the surfaces will interact with each other when they kind of approach each other. Does one lift to get out of the way of the other? Do they move together as a group? And just kind of shuffling the paper around physically helps you just very quickly get an understanding of that. It's a really fast, really cheap, even kind of fun way of designing. So when we're talking about just the structural possibilities for your app at the high level, all of the possibilities that you're used to seeing are still there. If your app wants to use tabs, that's great. We support that. No worries. If you occasionally indulge in using a left side navigation drawer, that's covered too. That pattern's there. If your app is all about search, we like search too. That's a pattern that you can support as well. As a designer or developer of your application, you are responsible for picking the most appropriate pattern that's going to best serve your users and their goals. So be sure to consider all the possibilities. Now, each of those will have its own set of advantages and disadvantages. I'll pick on the left navigation drawer for just a moment here. And this is a really suitable pattern if you have a large number of high-level views. It becomes effectively this very convenient table of contents to your application that the user can quickly access and scan and jump to a section. It can also be really valuable if your app has kind of deep paths through its hierarchy where the user can go down, down, down to deeper levels, because they can use the drawer as a rapid mechanism for kind of pivoting back and going to a different top level without having to go up, up, up first to do that. On the other hand, there are drawbacks to the drawer. It's clearly not as obvious as something like tabs, which are immediately visible on the screen all of the time. It also may not be ideal if the contents of the drawer are heterogeneous, if it's not kind of a standard list of categories or labels, because in that case, the user is going to need to spend a little bit more time using your app to familiarize themselves with what the content of that drawer is, because they're not seeing it all the time. On the other hand, that could be valuable if you're trying to demote some of that content, if those are less frequently visited destinations that you kind of want to politely steer the user away from, but make accessible in certain situations. So as every designer always says, it depends.
So the previous examples that Rich showed, and a lot of the screens that we've been looking at are all mobile, but the basic structure of our applications applies to mobile, tablet, and desktop layouts. The tools that we have at our disposal are all here. There's an app bar, there's a canvas area with a floating action button, there's an occasional bottom bar, and side navs that can be accessed temporarily. From a structural standpoint, we keep this stuff around no matter what the screen size is. So as we move up into tablet, the app bar can absorb elements that couldn't fit into the mobile screens, and the side nav bars can still be accessed temporarily as they were a mobile, or they can be pinned. Additionally, in our desktop structure, the side nav bar as well as content canvas area can have secondary toolbars for things like tabs or palettes or just secondary actions. As you'll notice in material design, these structural elements are all extremely flexible. They can move and react to screen sizes and different contexts in magical ways. So let's take a look at some of the family shots that we have to see what's happening. In this example of a file browser, you can see a lot of the stuff that we talked about in action. The header is extended based on a default height of the app bar. And this is really just to create a little bit of visual hierarchy in the layout for the tiles and the list. As you can see on the desktop screen here, the right nav is pinned while browsing. In the mobile screen here, we add intentional negative space between the line items just to separate the items with something other than a rule. And a similar app structure is maintained throughout our layouts. And you can see that here by the left nav being opened. Our responsive solutions combine fixed, fluid, and sticky elements that should be able to adapt to the way that people use their devices. You can see that here by the mobile screen. The density of information that's being shown relates to the amount of information that people want to interact with on their phone. On tablet, we can add illustrations, we can add photographs to make a more immersive and playful experience. And then when the screen grows, we can add intentional negative space again to separate content areas. The toolbar that's being shown here is also extremely flexible. It can rest on a background, it can be transparent over an image, or it can fit within any defined space. Our designs show a lot of variations in the toolbars to make them generally more useful and flexible. Sometimes we extend the top bar just to add a splash of color to our screens. We can use cards to keep text line lengths at digestible sizes when the screen gets bigger. Primary content can be higher in Z-depth or closer to the glass. In this contact screen, you can see that a left nav also might be pinned and scroll under the toolbar, while primary content in a card might scroll over the toolbar. You can also see here that what was full width on a mobile screen is now a floating card or a floating surface on desktop. You can also see one of our designers. In this music example, we're using a bottom bar for the player. We're using large photographs in the background and dynamic color choices. We're also using a floating action button, this little blue play button in some of the screens here, just to add a pop of color to the screen. Bethany's going to talk a little bit more about that. There's a lot of structural nuance that's happening in this screen. Our toolbars can have all types of content in them, from photographs to input fields. And we can use typographic scale by having dynamic type. Menus that generate from toolbars, they can come above other elements in Z-depth. And this plays into our story of real materials in real space that can do magical things. And not all of our toolbars are pinned to the top in a colored bar. They can be associated with a surface that's currently in focus. So if you imagine this toolbar here associated with this list view, when it scrolls down, that toolbar might come with it. So how does all of this content move? There's going to be a lot more details covered in the motion talk that's happening later today. But let's talk a little bit about scrolling. This is a common scrolling pattern that's happening here, right? Content moves up, the app bar scrolls off, and the status bar picks up a little bit of the color of the application and sticks around, which is something new with Material. Also, when a user scrolls back here, the toolbar can come back at a little bit of a different pace than the content. In this example, you can see how we think of the top toolbar in blocks. There's one block that contains the search field and another that contains tabs. On scroll, these are handled independently. So here we're pushing off the top search bar and keeping the tabs. And this is dependent on the context of the application. You can also see that on the slightest downward pull, the search bar comes back, right? This is where things get really exciting, right? We can have photographs that morph into colored bars in our toolbars. We can have a dynamic UI that removes itself from the screen in different ways. Our typography can scale and move. Scrolling and the way that things move is very much dependent on content and the context and the containers that hold our content. So with that in mind, Dave's going to talk more about components.
So now that we've covered Material and how it's structured, let's take a closer look at some of the bits and pieces that make up an interface and some of the best practices for implementing them. At a high level, one key thing you typically want to do is organize information to help your users make decisions. We support the expected forms of content organization, lists, grids, and now formally cards. Lists and grids are familiar and well understood. Lists are great for text, and grids are great for images. But the question of why and when to use cards has been a point of some uncertainty in the past. So here's some more concrete guidelines. Cards are great for displaying a set of data with different content types. Google Now is a perfect example. Stock quotes, weather, directions, World Cup scores. As a little aside here, any spontaneous booing or cheering during our talk will not be taken personally. Each card can have a dramatically different presentation, so making them separate pieces of paper makes sense. Cards are malleable and can easily handle data sets where content varies in length from item to item. In comparison, lists and grids have a natural bias towards regularity, making them best for consistently structured data. Each card can contain a heterogeneous mix of media, text, controls, and actions related to a single subject. Cards give you the flexibility to combine and create complex compositions of content and actions, such as +1 buttons, sliders, and comments in a way that lists and grids aren't simply designed to handle. But just because you can use cards does not mean you should use them. When deciding between lists, grids, or cards, first ask yourself, how can I best support my users' goals? Are they trying to find a specific thing, like a photo or a file? Grids and lists have a consistent rhythm and composition that makes them easy to scan and well-suited for quick comparison. In contrast, cards are harder to scan through because of their irregular cadence, but they are great for browsing diverse content and layouts. As these examples show, adding more pieces of paper, more ink, and more shadows to the screen increases noise and distraction without increasing clarity. Remember, you can always split an item into its own piece of paper the instant it's needed. So that's a brief overview of containers and some guidelines around when to use each type. Bethany will now cover more of the components and best practices to use when building material design interfaces.
So we looked at all the standard UI elements like buttons, text fields, and switches from a material design perspective so that they too will help you create one adaptive design for your app. And these goals of moderating complexity and of reacting appropriately extend into all of our elements. Our controls are designed to be consistent with the larger visual story. We use simple geometric shapes to build more complex but still cohesive components. And by building with paper and ink, our components have an enhanced ability to react to the user. For example, as elements come into focus, they become alive, hinting at what's to come by ebbing and flowing between the rest and the press state through diffusing ink and traveling through the Z-space. Element states have been simplified to help as you design across form factors. All of the element states are coordinated so that the same element will function correctly in a design that is being used with different input methods. You can see that each input method works nicely with the others without having to duplicate your control states. And as you create custom controls for your own app, you may want to follow a similar approach for quicker adaptability. I'm going to talk in more detail about buttons. There are 3 styles of buttons, and each is appropriate for different circumstances. The floating action button is known by its shorthand, the fab. The fab is the newest and has the most unique characteristics, while the others are more familiar. Both the fab and the raised buttons are made of paper in material design, and the flat button is made of ink. This pyramid illustrates the frequency of use of different button styles. The fab is the strongest in the visual hierarchy and is most rarely used. It's special. The raised button is used more commonly, but still sparingly. It's quite visible, but because it doesn't float, means it doesn't respond to Z-space changes in the same way that the fab does. And finally, there's the flat button, a very commonly used control. So I heard in the session yesterday there's a really good question that was basically, what are all the circles on the screen? And here it is. It's the fab. So it represents the single hallmark action for a screen. It's a tool for you to call out the key parts of your app's product story. It should be used for actions that are strongly characteristic of your app. Pausing or resuming playback tells me that this is a music app, or driving directions tells me that this is a maps app. Not every screen should use a fab because not every screen has an action with this importance or doesn't really have the right type of data. It's a natural cue for telling users what to do next also. So in user research, we found that users understood it as a wayfinding tool. Research showed that when faced with an onslaught of unfamiliar screens, as many users do on a regular basis, like when they install your app for the first time, they started using the fab to navigate. And users discovered that it was really useful as a signpost of what's important. And here the fab is being used in a variety of different types of apps. You can see how it highlights a hallmark action for each app. Compose for a messaging app, add files for a storage app, and so on. And you probably noticed that it can be placed around the screen. And we have a few recommended places that work pretty well, like in the lower right-hand corner. The fab is also the first element that is allowed to straddle a seam or allowed to hang over a paper edge, such as in the screen for people. And also note that there's only one fab per screen. There should never be multiple on screen at one time, as that confuses our visual hierarchy goal. You can use your app's accent color for your fab. Just make sure that you retain adequate contrast from the background. Because the fab is characterful, it's generally a positive action, like create, favorite, share, navigate, explore, and so on. And unless it's truly the hallmark of an app, fab shouldn't be destructive actions like archive or trash. They also shouldn't be unspecific or alerts, limited actions like cutting and pasting text, or stuff that should really be in a toolbar like changing the volume. Basically, the function should be an action that makes a user feel really positive about using the fab and never worried it's going to do something wrong. So it's not just a round button. It has some transformative properties that you'll be able to use to help ease your users from screen to screen. It can expand, morph, and react. The fab can replace itself with a sequence of more specific sub-actions. This helps surface a set that don't really belong at the top, but are still important. And you can design them to be contextual to your users. Imagine a user tapping the fab and their favorite people expanding out as contacts. And these do need to be tightly related actions, as well as ones which can be understood through the simple initial icon. So for example, if an add fab hides a search function, users won't naturally think to look there for search. And lastly, don't turn your fab into an action overflow. Those still belong in the app bar. So because the fab is made of floating paper, it can morph into a new surface that allows for richer interactions. For example, you can have a new post fab, which enlarges directly into a composition field or into an open camera viewfinder. It's not just a fancier drop-down menu. You're making your hero action even more heroic and reinforcing the sense that this is a core usage of your app. As you recall, fabs can be positioned along steps or seams of paper. And as that paper moves, the fab can transfer its anchor point. Reactions can be simple, as shifting a fab's position in response to other paper moving, like in Zach's example. Or as a user scrolls down a page, the fab can hop locations from seam to seam, or even off to a floating position so that users don't lose sight of that important fab function. So with that, you should have a picture of what the new material design elements are like and what the fab can do for your app.
So we've covered kind of the basics of material design, how the materials behave. We talked about layout. We've talked about structure. We highlighted a couple of key components. But as developers and designers who already have apps, the question on your mind is probably, what's next? How do I take these material design principles, this new system, and apply it to my apps? The good news is we haven't thrown out anything you already know. So all of the components that you're used to using, they're still there, they're still supported. We've given them a little bit of a refresh to make them more reactive, more alive. But they're still there and you can still count on them. As announced yesterday, there is a preview release of our new UI guidelines available at www.google.com/design. And this covers all of the standard components that we didn't kind of address today that haven't changed. So you can see all of those elements. You can get all the updated guidance on those. It's also packed with examples. So you may see kind of in those examples something that inspires you to think about the design of your app or part of your app in a slightly different way. Here's a screenshot from the spec covering the layout chapter. Just kind of showing a few wireframes, and it kind of clearly shows the application of the 8-dip grid that Zach talked about, and you can see some of the key lines called out. All of these guides have been responsively designed so that they'll work well on desktop, on tablet, on phone. You can check them on any of the devices that you're designing for. I wouldn't read them on your new fancy Android Wear, but everything else we've got covered. So this site will continue to evolve as our frameworks update. There are also a lot of really helpful resources, particularly for interaction designers on this site. So we offer a bunch of layout templates for the standard views. We have sticker sheets of all of the component types. And if you're thinking Android, they're in light and dark theme available there. And then there are also color palettes, icon sets, advice for animation, lots and lots of content there. But we'd like to leave you with a challenge. And that is to think about not just how you can make your app more attractive, more delightful by applying material design to it, but how can you use these principles to actually make your app easier to use? And one way to start on that is to question some of the design decisions you may have already made. So let's start with the biggest one, the question of how do I structure my application? We talked about structuring based on hierarchy in this talk. But another way of thinking about it might be to structure based on motion, kind of planning for all the different surfaces that you want to have moving between the different views within your application. What are those elements that should be lifted up, that are important, that want to get that signature treatment? Motion provides meaning to the user. It is a form of feedback which focuses the user's attention, and it builds a sense of continuity between different states within your application. So relatedly, how do you move to a model that is, it's kind of the old model we've been building in is this kind of screen, screen, screen style of design, where I start at the top of my app, and then I build all the intermediary screens till I get to the bottom of the app, and we just kind of realize those one at a time. We can do something much more fluid now. We can use transitions to give the user the sense that they can do more work in fewer places within the app by just kind of transforming the context slightly for them. So we can use animation to guide the user here, rather than just dropping them into some new context where they have to reorient themselves after they've landed from the teleport. You can guide them more easily, build up more that sense of direction and connection between these different conditions. And think about what you would do for the fab if it's appropriate for your screen. What is that hallmark application or that hallmark action that you'd want affiliated with your application? Or think of it this way. What's that action that you want to clearly show in the screenshot promoting your app that shows up in the detail page of a store listing? And what's the thing anybody looking at that should take away and say, oh, this app does this? And in general, how can you lean into the frameworks more? Are there things that you're doing currently in a custom way that no longer need to be custom, that can take advantage of some of the new APIs that are present? Can you make your code base faster, smaller, easier to maintain by relying on the framework more? There are 3 more excellent sessions today covering different aspects of material design. There's one starting at the top of the hour, and then later today we have sessions specifically on visual design and on motion design. We also have the sandbox space. If you've come by there, you've seen the new UI guidelines projected on giant touchscreens. We'll have a couple of small, short talks there. I'll give a talk at 2 o'clock on a little bit more detail about using paper and ink and how those work. But all of the designers here, as well as others, will be in that space. It's a really great opportunity to ask any questions you might have and just to come by and say hi. We're happy to meet you. And with that, thank you very much for your interest and for your attention today. And we'll happily take some few questions in the time that remains.
Hello, I'm Akil from University of Maryland, and I just had a question about the navigation drawer. What were the reasons behind moving the hamburger icon from the halfway beyond the edge to into the screen?
Okay, I think this question maybe relates most to Android. So kind of formally in Android, you'd have the application icon and then kind of a hint of the drawer indicator icon beside it. Part of Material has moved away from using the app icon as kind of the visual identifier of where you are. And we try to encourage developers to express the app's identity more through kind of those standards of color and typography and treatment to kind of make each view more characterful and more immediately recognizable. So as we moved away from using the application icon, we wanted to give a full width affordance in that space for opening the drawer.
Thank you.
Sure.
Hi. This is essentially paper, but I haven't seen any folding. Is there any specific reason for that?
Yeah.
So one of the things I talked about was this notion of perceived z-depth. And so when you're handling a phone, you have the sense of the thickness of that between the glass and the back of the phone. So we want to preserve the notion that there's a finite amount of space to use. And so if you start folding things, then that would sort of break the plane.
Okay.
That's something potentially you could explore maybe on deeper z-depth environments like televisions when you start thinking about 3 dimensions. But for now, we're really focusing on keeping things in a single z position and sort of moving things laterally.
Okay, makes sense. Thanks.
Yeah.
Hi. So mainly I wanted to ask about, for one, backwards compatibility to getting these new patterns into, like if, as far back as like gingerbread? Is that possible? And then also, for low-end devices with all these new animations, what are things that, like, is it just better not to use those, or what are good guidelines?
Sure. I think kind of my take on the best practice is you want to kind of design for material design first and foremost. We found that the translation exercise of taking something that's designed for material and kind of simplifying it downward has been a reasonably straightforward one. I mean, most of the same elements are still there. You still have things like action bars and toolbars. You can make them less transformative as the design kind of goes down to earlier versions. And some of these changes will actually be supported through the support library as well. So I think you kind of start with the highest end, you simplify to pare it down, and then you still have a design that feels very coherent. Material has a unique theme on Android, so you can target that theme and build against it, and you can kind of see what happens on that right away. The second part of your question was, sorry, just remind me quickly.
Low-end devices.
Low-end devices, yes. So the animation framework will actually be aware of kind of the capabilities. It will basically shorten or remove animations in some cases to make sure that instead of just getting like a very janky or stuttery animation, you sometimes just get a clean cut or crossfade instead of more elaborate one. So it's not as full of an experience, but it still feels kind of complete for that device.
Okay, thanks.
Sure.
Hi, I have the skeuomorphism question.
Okay.
Wondering how that went internally, and do you guys consider this skeuomorph?
So skeuomorphism. So that's the notion of sort of introducing really kind of like ornament and unnecessary elements into design. And I would say that in this case, we're trying to use paper as an inspiration, but it's an interesting question because I guess the most amount of skeuomorphism that you could potentially call skeuomorphism is effectively shadowing, because effectively they're just pieces of paper that are moving about. There's no additional ornament beyond it's a blank piece of paper that you're adding ink to. The idea there is that we're trying to add additional affordances so people can more intelligently understand sort of what's going on. There's conversations if you're in the design world talking about flat design and post-flat design. Arguably, this is kind of post-flat design because we're trying to take the direction of flat design, which is kind of the answer or the response to skeuomorphism. That's at sort of one extreme end of the spectrum. We're trying to pull it back and say that we do kind of need to introduce a little bit more affordance here and give people, users, guidance as to like how things work, how they relate to each other, what to expect.
Yeah, just to add to that, I think we're at a place that's kind of in between the flat and skeuomorphism. There's a lot of our stuff is flat on first appearance, but it's tangible and you can touch it. And when you do touch it and interact with it, it feels real. And I think that's a kind of place that's in between pure flat design and skeuomorphic stuff.
Cool.
Yeah.
Thank you.
Yeah.
Sure.
Hi. You'll have to forgive me if this is a basic design question because I'm a developer, but you mentioned that it's important to have the fab's primary color work well with the image content behind it. I'm just wondering if there's sort of a way that you determine what that is dynamically based on the content, and if so, is that available in Polymer and Android?
Yeah, the library is called Palette. It is a way of extracting the dominant color value from an image and then using that to select the complementary color that's appropriate. I think there are a few cases where the fab would want to do that. I think the fab in particular often wants to be kind of a known fixed color for just kind of easy identifiability kind of within your app. That said, there are a couple of contexts where it makes sense to do that, but it is supported, and Palette is the name of that library.
Thank you.
Sure.
Hi. Fab definitely stands out for me in this talk, and I think through the whole conference, designing for cross-platform is one of the main themes this year. So I'm just wondering, any thoughts on how to apply Fab in TV space, like in a TV UI? Because for most of TV, remote doesn't have a touch screen, and it still operates on D-pad. So I'm just wondering, any thoughts on that?
Yeah, so the fab is a raised button, which still has a focus state, and I know that a lot of our TV UI relies on moving the focus state around the screen. And in a lot of our apps on Android TV, we've actually used the fab very successfully using focus to pull it out. So it still works.
Okay, thanks.
Hi, my question is kind of related. So I love what you've done to, I guess, facilitate design cross-platform. So I'm wondering if you're working on a product that is still primarily desktop and might, it's still kind of becoming responsive, but it's still desktop. Do you feel like some of these things, like the new animations or the metaphors of paper and ink, is that still appropriate for a primarily desktop application, or does it require interaction via touch?
Yeah, I think it's still appropriate. A lot of the Polymer stuff that we've been working on implements some of these touch ripples and animations, and you can kind of get some of that stuff for free by using Polymer elements in desktop. But I think it totally still applies, and there's definitely, on mobile there's no hover states, and there's definitely differences, and I think we're trying to respect those differences in the different form factors, but just from a structural standpoint, keeping all of the same stuff around is how we're keeping consistent across form factors.
And as Bethany and I both sort of discussed the notion of the fab transforming and also just paper hierarchy, I mean, some of those things still apply to desktop, so you can start talking about how the fab transforms into new paper, and that helps cue users that there's a new activity or a new action being, when you're composing a new email or a note or something, that can turn into a new piece of paper and helps give them some sense of relationship with that new surface with the work that they've been previously doing.
Have you found that users, that their relationship with the mouse in the screen is kind of similar with the relationship to just clicking on a screen? Have you kind of explored that?
There's a bit more difference. I mean, I don't think any of us are too close to that work specifically, but I know from the development of the Pixel that kind of users sometimes move between those modes of engagement. Like when a touchscreen is available, that's appropriate for some kind of lighter browsing-oriented activities, but kind of for the more precise targeting and more kind of work active, I'm alternating between keyboard and mouse. They tend to bias towards that affordance.
Okay, thank you.
Sure.
No, not me.
All right. Well, thank you all again.
Thank you.
Thanks.